This is the second half of lesson 11.3. We're going to start with a little bit of vocabulary. A set of data is said to be discrete if the values belonging to the set are distinct and separate. Usually these values are found by counting. Notice we said usually, but not always. There are some exceptions. So some examples of discrete data are the number of children in a class, another example is shoe sizes. Okay, so I know I just said usually you find discrete data by counting, but that's not always the case. So the number of children in the class you would find by counting. Shoe sizes aren't found by counting, but the reason they're discrete is because they can only take on certain values. 5, 5.5, 6, 6.5. I think the best way to tell whether a number is discrete or not is if it can be an ugly decimal, it's not discrete. So shoe sizes can be a decimal, 5.5, but it can't be like 5.587. Okay, if a number can be an ugly decimal, it is called continuous. Usually, but not always, these are found by measuring. Some examples of continuous data are the weight of let's go with the weight of an apple. So how do we find the weight of an apple? We measure it on a scale. Could that be an ugly decimal? Yes, it could. Another example is the time it takes to run a mile. So that's not always an ugly decimal. It could take you exactly 6 minutes to run a mile. But could it take a little longer? Could it take you 6 minutes 10.562 seconds? Yes. So if it could take on any value within a reasonable range, then it's continuous. If it can only go up by certain numbers, like shoe sizes, which only go up by half at a time, or a number of children, which only go up by a whole number, then it's discrete. Right, for these examples, I crossed out the first part of the directions. Identify the random variable in each distribution. That's kind of pointless because for number 3, the random variable is the number of strikes thrown by the pitcher. For number 4, the random variable is the mass of a cell. And that's how it is for the other two as well. So instead, we're just going to classify it as discrete or continuous, and then we're going to explain our reasoning. The number of strikes thrown by a pitcher, that would be discrete. The number of strikes thrown by a pitcher can only be a whole number. It cannot be an ugly decimal. So, explanation would be that this number must be an integer. Technically, it must be a natural number or a whole number because it can't be negative. Okay, the mass of a cell. That would be continuous. Not sure what the units are for measuring the mass of a cell, but could it be an ugly decimal more than whatever it was before? Yes. It doesn't always have to go up by a nice number every time. So I would say continuous, and that it can take on any value within a reasonable range. So you're not going to expect the mass of a cell to be 2 tons, but could it be any value from 0 to 1/10 of a pound? Yeah, it can be any ugly decimal in between. The number of chapters in a book. This is discrete. Some people might argue that they read half a chapter or 3/4 of a chapter, but the number of chapters that the book has to be an integer. So the number of chapters in a book is discrete. The number of chips in a package. Some people might argue that what if the chips are broken? So let's just assume they're poker chips. So this is also discrete. We find them by counting. They can only go up by 1 at a time. So I'll say this is discrete. Must be an integer. Alright, now we're going to do some math. So referring back to the 11.3a notes, we need to find the expected value for the number of heads. Expected value is just another way of saying the average. So we're going to find the average number of heads. So if you flip a coin 4 times, the average number of heads, I would just guess that that would be 2. But I will show you mathematically how to do that. So what you do is you take each probability and you multiply by the value associated with that. So one possibility was we could get 0 heads. The probability we found of that happening was 1/16. We also found that there was a 1 in 4 chance that we would get 1 3/8 of the time. We would get 2 heads, plus 1/4 of the time we would get 3 heads, and 1/16 of the time we would get heads all 4 times we flip the coin. So if you add all these values up, you get 0 plus 1/4 plus 6/8 is 3/4 plus another 3/4 plus 4/16 is 1/4. So 1/4 plus 3/4 is 1 plus another 3/4, and another quarter makes another 1, so the total is 2. So if you flip a coin 4 times, the expected number of heads, or the average number of heads you would get, is 2. Okay, for the standard deviation, you should do this on your calculator. In L1, I want you to put the different values that we could have for the number of heads. So 0, 1, 2, 3, 4. And in L2, I want you to put the probabilities associated with each of those. So those were 1 over 16, 1 over 4, 3 over 8, 1 over 4, 1 over 16. Then, okay, so if you don't remember how to do that, push stat, and then edit, so stat, enter. In L1, type 0, 1, 2, 3, 4, hit enter after each number. In L2, 1 over 16, enter, 1 over 4, 3 over 8, 1 over 4, 1 over 16. Then, to get the standard deviation, you're going to go to Stat, Calc, and then the first one, 1 var stats. In list, you're going to put L1. If it doesn't already say L1, you can type L1 by hitting second and then 1. Frequency list, we want L2, so hit second and then 2 to type L2. Then go down to calculate and hit enter twice. So you'll notice that the first bar, or the first line, says X bar equals 2. X bar just means the average. So we could have found the expected value by just doing this and finding X bar. Look at the fourth line. The fourth line has a Greek letter sigma. Sigma represents the standard deviation. So our standard deviation for this problem is 1. Alright, now we're going to find the expected value and the standard deviation for the other problem that we did in the first half of this lesson. So find the expected value for the sum of 2 spins. Okay, so go to Stat Edit in L1, or you could do this wherever you want. You could do it in L3 or L4, just don't forget where you put it. I'm just going to put it in L1. So in L1, I have to put the values for each of the possible sums of 2 spins. So 2, 3, 4. Every number, every integer I should say, from 2 to 12. Okay, in L2, next to each of those. So you might want to go to the top of L2 and push clear enter. So to delete a whole list, to empty out a list, you put your cursor on the title, L2, and hit clear enter. Okay, next to each of those sums, I need to put the probability for each. So 1 over 36, and I have them memorized. 2 over 36, 3 over 36, it just follows a pattern. 4 over 36, 5 over 36, until you get to 6 over 36, and then it counts down from there. 5 over 36, 4 over 36, 3 divided by 36, 2 divided by 36, and the last one is 1 over 36. Alright, so now I'm going to do this one on the calculator, not by hand, like on number 7. I go to Stat, Calculate, 1 variable stats, L1, L2, calculate, And so I get the expected value, which is written with this variable, x with the bar over it, equals 7. Going down to the fourth line of that same screen, I see that the standard deviation is 2.415. I'll round it to 2.42. So what that means is the average value, if you total up the sum of two spins, is 7. And then typically, how far is the sum away from the mean? Typically, the distance from the mean is 2.42. Sometimes you'll spin exactly 7, so then your distance from the mean is 0. Sometimes you'll spin a 12, that makes your distance from the mean 5. But the average distance from the mean is 2.42. Okay. Mia is thinking about investing $10,000 in 2 different investment funds. The expected rates are shown. Compare the 2 investments. Which should we advise her to choose? Okay, so the things you want to compare here are the standard deviation and the mean. So I'm going to go back to Stat Edit. I'm going to clear out L1. I'm going to clear out L2. In L1, I'm going to put the different possibilities. So I'm going to put 2,000, 1,200, negative 200, negative 500. In L2, I'm going to put the probabilities associated with these. So I always like to put the probabilities second. Even though they show us the probability first and the profits second, I put the profits in L1, the probabilities in L2. So the way I type 20% is 0.2, 0.2, 0.3, 0.3. So in L1, I have the different profit levels. If it's a loss, I put negative. In L2, I have the probabilities. All right, now I'm going to go to L3. And I'm going to put in the profit values 1750, 1000, negative 500, negative 800. And in L4, I'm going to put in the probabilities for each of those values. 0.4, 0.1, 0.1, 0.4. Okay, first I'm going to calculate the statistics for Fund A. Stat, calculate one variable stats, L1, L2. So the way I want you to show your work is, you can write L1 here. You can write L2 here. That's a 2. And then say 1 var stats L1, comma, L2. And so if we calculate those, we get the average is $430. And the standard deviation is $995. And I guess with money, it's always good to round to 2 decimal places. Alright, and now let's do it for Fund B. So, same thing. 1 var stats. And I put those in L3 and L4. Alright, so you will get an error if you don't put the probability list under frequency. that, calculate one of our stats. So where it says list, I want to put the money values, which I stored in L3. Where it says frequency list, you need to put the probabilities, which I stored in L4. Calculate. This one also has an average of $430. It has a standard deviation of $1,192.10. Okay, when making financial decisions, you probably want to choose the option that has the higher average value. In this problem, both investments have the same expected value, so we should then look at the standard deviation to make our decision. So if you want to be conservative, you want to pick the lower standard deviation. Look at Fund A. Fund A is more conservative. It has only a 30% chance of losing $500. In Fund B, there's a 50% chance of losing $500 or more. So if you want to be more conservative, you choose the fund or the option that has the smaller standard deviation. What that means is there are more values closer to the average. For Fund B, while it's not as conservative, it does have more of a chance for larger gains. If you look at it, there's a 50% chance of a $1,000 profit or more. Looking at Fund A, there's only a 40% chance of getting a profit of $1,200 or more. So Fund B gives you a higher chance for big gains. So to sum up what I said, usually you want to choose the bigger average profit, and if they're the same, then you could either choose to say that you want the bigger chance for larger gains, which is the bigger standard deviation, or if you want to be conservative, you can say you want the option with the smaller standard deviation. So I'm just going to choose Fund A. Fund A. It has the smaller standard deviation, which means it is less risky.